Okay. All right. So question 13 is find the employment age of each employee. So let's do that by logging to Oracle. It is a developer. Okay. All right. So you're trying to find employment age. So let's just say I want to get the employee name first, and then for employee age, I will just use toChar convert sysdate, which you get the current year number, y. Okay, and then minus toChar, that will be higher date, and also get a year number only. So use current year number minus the higher year number. Let's just say as employment age. Okay, from EMP. Because we're doing that for each employee. So each employee is one record, so there's no grouping, no anything. There we go. These, I think we just created a 0 because we just created this year. All right, next, you said what? Which one? 18? Marina?
Yeah, it was 18.
18, okay. For all employees working in Dallas, list the name of each one and the number of years he has been employed by the company. Okay, that's basically the same thing, but just add information about Dallas. So we are going to do join. Okay, so select ename, and then also employment age. You can just copy and paste here. Okay, and then this time we need to get information about the location, so we need to use join. Let's just do inner join here. Inner join emp on depd number equals to emp.depd number. Okay, and then where location is equal to Dallas. Okay, so basically it's kind of similar to that, but just use join to get two tables. So you can use equal join or implicit join to do the same thing, and the inner join should be faster. All right, any other questions?
Professor, I have a doubt on question number 27.
27 is the name of each department, and there is a total number of employees and the total amount of salaries. Okay, so here, name of each department, so you need to group by department, right? Because you are doing total salary, total number, and also total amount. So let's just say you are going to, let me put this back here. So you're going to select the name and then count employee number, okay? And then sum of salaries from, so again, we need to use both tables, so we have to do join. In join, then emp on equals emp.depd number. Okay, and then we need a group by dname. Okay. And then make sure that the group label is department name, so you have to use exactly same label in the select. Okay. You have any questions about this?
Can we use right join instead of inner join?
Can we use a right join instead of the inner join? I guess So if we do right join use EMP table as a right join. Let me save them.
Yes, I've used EMP right join department and it displays all the departments, showing operations department as none. I'm not sure if that is the right way.
Okay, so that might be. So let's see if I do that. The inner join we have count. So there's a production department. The one employee has no salary, so that's why you have that. So let's just do right join in that case. So if you do right join, so basically the idea is that you are going to get all the employees, whether there's a matching departments or not. And then you are getting one employee does not have department, right? Is that correct? Or two employees does not have department? Okay. So I guess it's not wrong. So the question was asked you to get all the names of departments and their total salaries, blah, blah, blah. So in my case, I have some employees does not have department. So I have two employees does not have department. So listed as null, department name as null. Salary is also null because I don't have salaries for them. So it really depends on the data. So does every employee have to have department? Then if yes, then right join should give you identical result, I think, because every employee must have department, right?
So Professor, the question says list the name of each department. So I think if we use left join here, then we get all the departments. Then whether that department has employee or not, it will count. It will give us the count and sum of salary as well.
Okay, let me try to say. You think if you use a leverage join, you might get easy. So leverage join will get all those names, but then those departments have no employees with more values. That might be even better. So in that case, for example, we have accounting. Okay, production, say operation has no employees, and then we're zero count and also no salary. So I guess this leverage join probably is even better, because the question was, let me see the question. Question is for each department, list the names, or each department name, and then the total number of employees and the total amount of salary. So that means that your focus is on the department. Yeah, I think left join problem a little bit more sense.
I've taken employees right join department, focusing on department.
So if you say employee right join DPT, that will be fine too. Yeah, that will be fine
Yeah,
too.
that will give the same result, right?
That will give you the same result. Yes.
Okay, thank you.
Yeah. Okay. Any other questions?
I actually have another question on that
On which
question
one?
that we were just going over. The 27 with what you had written. I have a note from last class that you can't mix statistics and individual records. So I thought you couldn't put select, dename, and count and sum in one line item.
There's one exception. There's one exception. Usually you cannot put a column name along with this group statistics, but you can. There's one exception is you can put the group label. So here we group all the employees by their department names, right? So each group.
Okay.
Each
Yeah,
group.
I forgot about that. Thank you.
Yeah. Okay. Any other questions?
I still have doubts on how to use outer join. I mean, in which situation we can use. Can we have any more examples?
Outer join, examples of outer join?
Yeah.
So if you do outer join, basically let's just say, I would try to say I put a department name, and then DPD number or DPD.DPD number. Okay, and then EMP ename, and then DPD EMP.DPD number. So that way you see 2 columns from each table, from DPD, comma EMP. So if you do this, this will create an outer join, which will basically just get a combination of every department with every employee. Does not matter whether they are matching departments number or not. So let's see the result here. All right. So for example, first record operation for the department 40, but the employee is actually department 10. So they don't match, right? See that? So even that is the case, it will still be listed. So basically, you're going to just get a combination of every record from each table. So for example, if this table has 10 rows and this table has 100 rows, then you're going to get 1,000, 10 times 100, like that. So this is auto join. So what happened here is if you use, all before 1999, and there was no join concepts, like join, explicit joins. So people have to use so-called implicit join, implicit, I think sometimes called equal join, to say that DPD.DPD number equals to EMP.DPD number, and that way you create a join. So basically that join is starting from this outer join. Okay, why do we need that? Because to do equal join, we have to create that join first. So that's not the worst. If the worst case, if you have like 3 tables, just say we have another table, DPD table, EMP table, and then suppose we also have a customer table, something like that, and that would be disaster, right? So basically, you just multiply combination, create a combination of every row from every table. So that is expensive. Okay. So if you're trying to create a join out of 3, 4 more tables, then that the outer join will create an exponential number of rows before you can actually filter them out and then create the result you're looking for. So before you apply this, whatever foreign key value equals to primary key value, before you do that, you have to create this huge table first. That is outer join. Okay. Now, let me see whether you have questions on this. No question?
I got it.
You got it. All right. All right. Any other questions?
So, Professor, I have one doubt regarding the hire date.
Date? Which one?
Like in some of the questions, it is mentioned that, let's say, for example, the number of employees who hired after 1980. So,
Yeah.
what could be the options to represent this condition?
Okay, so there are a couple of ways. Let's just say, suppose I want to find employees. Let me say whether I have any questions.
Actually, I have pinged in the message.
You send me a message?
Yeah. So I found these 3 in 3 ways we can represent this condition. I just wanted to make sure if any of the condition works.
So I cannot say, when I do sharing, I cannot see your message. Can you just speak out? So what is the question?
Yes, so if you want to find the number of employees who got hired after 1980.
Okay, number of employees. Do that. Hired 1980.
Yeah.
That's it. So you do say select one EMP. So we're going to use select cases. So higher date. So how do we do after 1980? So there are a couple of simple ways will be that higher date. And then after the greater than, after 1980, you can interpret that as after December 31st, 1980, right? 41st. Okay. 1980. So that is one simple approach. Or you can just say use let's to just trying to get a year, get like a date, higher year. Okay, so if that is the case, we can use any special way of saying the date. So let's just do that. Okay, so we'll say from EMP, and then where higher date, and then just say for the higher date, I'm going to just get a year number. So let's say a higher date. Okay, so it's greater than. So I will just get, for example, 90 information is only 1980, right? So I'm gonna just convert that to date. So to date, and then was put character 1 1980, and then that should be interpreted as a year number. Okay, so based on the text, say this is all the information you are given year 1980, then I'll convert that to year to 1980, and then we say higher date is bigger than that. That should be kind of a little bit more precise than the first one.
Okay, can you also use where to char higher date, comma, in single quotes y greater than 1980?
Oh, let me say do select count, and then you see that from EMP, and then you're trying to get your number, and then say to char higher date, and then y is greater than 1980. Is that what you're trying to do?
Yeah, right.
Yeah, I think that's probably also correct.
Okay. Yeah, I just wanted to make sure that any of the above three options would work correctly.
Yeah, I think there are many ways to say that. Yeah.
Okay, thank you.
Yeah. Any other questions? Okay. No questions? No more questions? Then we're going to move on to lecture note number 8. For number 7, I updated. So after the class, I copied all the examples we did and then put into the note, so that this has been extended. Okay, so let's do week 8 of that. So basically, this is not a week 8. I think it's a week 10 already, right? We had one day for review and 1 day for exam. So basically, we had like 2 weeks in the middle, which was not. I tried to make a homework to be consistent with these week numbers, so that we don't get confused. So, for example, week 7, you have homework 7. Week 8, get a homework 8. So that way, that's how we label that. So basically, this week and next week we'll be doing online classes only, and after that, let me see, what time would that be? Let me check. So November 4th, we do online also. Then November 11th, next 2 weeks, we'll be doing hybrid. So you're welcome to come to the site to take the class. Today I got a message from department, and then one student, not my class, one student was complaining to department saying that some professors are using outdated recordings to let students, just listen to those old, like 2 years old recordings. And then the students are very mad. And he was saying that, we paid the tuition, why we have to just listen to those outdated recordings. And then there's no professor teaching the class, something like that. So basically, I think that would be a problem. I do feel that the students have the right to say that, and I really encourage students to just come to the classroom to get a real learning experience. Okay, so for this week and next week, we'll be doing online. But the good thing about this, we are doing synchronous or synchronous. So basically, You can stop me, ask questions, just like a regular class. But I think this on-site class is still more interactive. Okay, so we have 2 weeks of that, and then after we're going to have like a winter break, right? Thanksgiving break, and then after Thanksgiving break, we'll be doing all online again because that's university-wide policy. I don't know whether they changed that or not, but there was announcement that after Thanksgiving, all classes will be moved to online. Okay, so that will be the schedule for the next few weeks. Now let me open up the week, insufficient privilege. Open up week 8 outline. So today we are going to do advanced queries. So it's next week we'll be also doing advanced queries. This advanced query is kind of a combination of simple queries. So if you are comfortable with the last 2 weeks SQL statements, then you should have no problems with today's query. But you will see that today's query is going to be more complex than the old one. Okay, so that basically, you whatever the group functions, finding statistics, so also finding individual records that we did at the beginning will be utilized today to come up with more complex queries. Okay, and before we move on, let me repeat the rule of the game again. Okay, rule of SQL programming. Okay, first, one query for one problem. Okay, second, yes, program has to be based on what is given without actual assumptions. So these are the 2 rules we need to follow. So today you're going to see that. So you understand, I explained it to you that one query, one problem. So if you say, the SQL statement is so hard, can I split into 2 statements or 3 statements, or sometimes even more statements? No, that is not allowed. Secondly, if you, for example, you're trying to find employee who is making more than Smith, then can we, for example, assuming that I use another query to find the Smith's income, and then before I go to do this query, or for example, if I say I want to update Sarah's job title to another title, can we assume that Sarah has employee ID 1001, something like that? No, you cannot assume that. Okay, you have to based on what is given to you. Is that clear? So those are the 2 rules will be strictly followed. And if you violate that rule, then basically, even though your query statement is correct, but it will not be counted. Okay. So let's just do few simple examples to warm up. Okay, the basics. First will be basically just sorting or finding individual records. Okay, finding individual records. So in that case, there's no groupings, there's no groups, there's no having whatever. Okay, so basically we're just trying to find individual cases. So if you think of this as like a statistics, so using statistics, you're getting like a Minitab or Jump, whatever, and then you select cases. So you're just trying to sort for those cases. So basically, the first type of statement, that's what we did 1 week before or 2 weeks ago was finding individual records. Okay, so suppose I want to find out the department that are located in Dallas. So I will say select D name from DEPT, and then we say location is equal to Dallas. Okay, And then let's do it again. Suppose I want to find the employee hired between 1980 and 1989. So we'll say select e-name, hire date. Okay, from EMP table, and then say where hire date, say between. So when you use a between, make sure you do smaller number first and the larger number next. So 1980 and 1989. So basically 1980 is smaller, right? So we can just say to date 1980. Make that to be year number. And to date again 1989. And that's also year number. Okay, so in that case, we are finding individual records, individual employees. Okay, and we can also join multiple tables to find individual records. In that case, we are going to join first. So let's say I want to find employees located in Dallas. So we'll do select e-name from DEPT inner join EMP, and then we'll say on DEPT.DEPT number equals to EMP.DEPT number. Okay, and then say well location is equal to Dallas. Okay, so in that case we are finding records that cross using information from multiple tables. Okay, so all these cases are selecting individual records. And then we learn how to do groups, how to do statistics, all right? We talk about 4 different cases. Remember the case 1 was to no case selection, and also no case groupings, division. Okay, so in that case, we basically just say I would just simply just get a statistic. Suppose I want to get the range of salary, so that will be max of cell. And then it's just trying to create a max cell and then like an interval, right? So let's just say use this single quote, parentheses, single quote, okay? And then we do pipeline, and then trying to map, put first minimum salary, okay? And then after that, let's just put a comma, so pipeline means add characters, add a text together, so that will be single quote, comma, space, single quote, okay? And then add that to max of salary, okay? And then after that, I have a right parentheses. So right parentheses, pipeline, and then single quote, right parentheses, single quote. Okay, that's it as range. Okay, then from EMP. So in this case, we are doing just group statistics. Let me run this one, just make sure there's no errors. No, this one. What's going on? Oh, this one is wrong because I moved, it's supposed 2 dashes. Okay, 2 dashes. Still wrong. So what is going on here? Let me see. Oh, I have to, more comments here. More comments here. Let's do it again. So hopefully this one is working. Still wrong. Line 38. Which one is line 38? Missing right parentheses. Line 38. Where's line 38? Can I see line 38 somewhere? Line 9. So my screen does not give me. Okay, so now I can see the line here. So 9. That's 16, 24, 34, 38. I think it has something wrong here. All right, let's see. Between to date, I think it's referring to this one. Double quotes, single. So it should be single quote. Single quote. Why is giving me always double quotes? Oh, I have two. Okay, single quote. Okay, sorry for that. So that was not tested. Okay, so now it's working. Now let's test this one. So this is the SQL developer basically is going to check every statement before I move on to the next one. So now you get a range. So that is between 800 to 5,000. Okay, so that is correct. So in this case, we are not selecting cases for statistics, and we're not doing any like a factor analysis, putting cases into different groups. Okay, so the next case will be, say, select cases. Select cases. Okay, so that is very common in your statistical package. Say you want to use certain cases for doing statistics, right? So let's say I want to do this case. I want to find out how many people working in Boston. Okay, so we'll do count number of employees, employee number. Okay. Working in Boston, so from DPD in join and EMP, and then on DPD.DPD number equals to EMP.DPD number. Okay, and then we from that join. Say basically the join will create like a temporary table, and the temporary table will get information from both tables. But then this table is much smaller than the table you will typically get from the outer join. And then you want to find, so in this case, you're going to select cases. So where location is equal to Boston. Okay, so that will be selecting cases. Okay, so this is a very nice thing. So if you use statistical package trying to get data from multiple results, you have to do many mouse clicks and trying to do that. But here, trying to create like a temporary table, okay, and then you can do based on statistics doing that. So basically here we are just simply doing one statement joining the result, okay. And then in this case, we are using this temporary table to select cases that all the employees' location is not Boston and trying to find the statistics. Okay, so that's selecting cases. And then the next case will be factor analysis. Okay, so here we will use a factor. So in this case, will be some kind of like a column value, okay, or maybe expression value, and use those columns may have different values, right? So I put cases into corresponding to different levels, different factor values, and then group those cases, and then doing statistics based for each factor, right? So you can just imagine this factor could be male, female, right? So if you want to do, for example, some kind of like, say if you're trying to test medical, some kind of effect of a medicine, whether there's any difference between male and female, right? So you're going to do group analysis, put the observations into male group and the female group, and then come up with average effect, say whether they have a kind of a similar effect, right? So this will be, so in this case, we'll be doing a group by male, group by gender, right? So let's say if I want to say whether there will be any difference between average salary between different job titles. So we'll do select average salary, AVG of cell, okay? And then let's say use department number only, okay? From EMP. And then we do group by job, not department, it's just job, job. So trying to get say whether average salary for different jobs are pretty much equal. Okay, so we can do so group by job here. Okay. or even better, we can just get a mean value of every salary, and also we look at the standard deviation of salary. Okay, so we also can do the STD DEV of cell. Okay, and then for each job. So that way you can use that, do some kind of use the average and the statistic to come up with some kind of statistic to see whether they have equivalent some kind of equivalent salary. So for example, clerk has 1,000 and the salesman 1,400 average, and the president is 5,000. Okay, so it does have some difference. Okay, have the standard deviations here, okay, to see whether they are really equal or not. Okay, so this will be just like a factor analysis case. And then finally, we learned how to, of course, you can also, when you do factor analysis, you can also select cases, right? So factor analysis along, just analysis with case selections. Okay, so let's try to do one here. So suppose I want to find out total number of employee, let's say minimum salary for different departments for only those employees hired before 1983. Okay, so let me do that again. So suppose I want to find out for each department. So basically I need to group employees into different departments. A department has many levels, right? I need many values, 10, 20, so on and so forth. Okay, for each level, I want to find out what is the minimum salary, mean salary. Okay, and then from EMP table. And then we are not looking at all cases. We all want, say, suppose I want to find out whether minimum salary has anything to do with department for those people hired before 1983, for example. So we only select employees from hired before 1983. So we'll say hire date. Okay, and then let's say before 1983, so less than, and we'll just interpret that as 01 January 1983. Okay, so we are selecting cases, and then we group by the PD number. Group by. Okay, does it make sense? So here we do factor analysis, but at the same time we select cases. So that it would be a fourth case. And the last case is select factor levels. Okay, so let's say if I want, based on statistics, to select certain levels of a factor, say if I want to find out, say which gender has has average effect more than, say, something like a 0.9. Okay, so in that case, you not only do factor analysis, but also you want to use that factor analysis to find out which factor has the effect you're looking for. Make sense? So in our current example, suppose I want to find out the year that the company hired more than 3 employees. I'll find out the year. So basically every year we hire a certain number of employees, right? So we want to find out those years that company hired more than 3 employees. So again, we are using this method to find out the particular factor level or attribute value or expression value, so that at that level, all the cases belong to this case. Based on the cases that at that level we have the statistics we are looking for. Okay, so let's say I want to find out the department that have we just said that final year we hired more than 3 employees. Let's try to do that. Okay, so select. Okay, and so basically just get a year number, right? To char hire date, and then y. Okay, and as a higher year. Okay, from EMP, and then we need to do factor analysis, so we need to group by the same thing, by the 2 char, the year number. Okay. And then so basically this is doing, we do group by that basically is doing factor analysis. Okay. And then we divide all the cases into multiple levels. Okay. Based on this case, in this case, different years, different higher years. And then we're trying to find the year that, that particular statistics is what we're looking for. So what we're looking for is the count of employee number is more than 3. So the particular year that we hired more than 3. Okay. So you can just imagine that, you do a medical test and then, you want to find out, which group has the effect that is satisfactory to you. And then you can, this statistic, this SQL statement will help you to find that. Okay, so 1981 have more than 3. All right, so that basically all the basic cases we have covered, and now we are going to do advanced queries. So advanced query is going to be combination of those basic queries. Okay, so everything after here will be basic cases. Basic queries. Okay, so now from that, after this point on, we are going to do so-called sub-queries. Okay. So what is sub-query? Sub-query is just another query, which is one of these basic query, or maybe just combination of basic queries. And you suppose you're trying to do something that you're trying to write some kind of statement, but then somehow you do not have enough information for you to write a complete statement. Okay, so let me start with example. Just follow this example today. So first one says, find employees who make more than Blake, right? Who make more than Blake. So let me just copy that. Okay. And it's tempting to do what? It's tempting just to go to the database to find out how much does Blake make, right? So you're probably trying to do something like this. Select salary from EMP, okay, and where name equals to Blake, something like that. Try run that, and then you get a number. Okay, which is 2850. And then you're trying to do, say, I want to find the employees who make more than that. Select, okay, name, or maybe it's also salary from EMP, and then say, well, salary is bigger than 2850. Okay. Now, if you do that, if you do this, if you're trying to write 2 queries, trying to write a queries to answer this query, this problem, this question, I said is violated the rule, right? I violated the rule of the game, which is 1 query, 1 problem. Okay, and also program has to be based on what is given without actual assumptions. So you cannot just say, I can find that Blake salary and then just write this query. Okay, that's also wrong. So you cannot do that. Okay, so how do we do this? Now this is what we do. So in this case, this query is what we need to find the Blake salary, right? So why don't we just do this? So here, instead of assuming that we find out that, so basically say that find employees who make more than Blake. So I don't know how much Blake makes, right? So I can use question mark to replace that, right? So basically we have unknown here. The unknown is how much does Blake make? So how do I find this question mark? To replace the question mark is simple. Just put inside the parentheses and then make this query statement go inside here. Okay. And then this query, this statement will be satisfying the rules we set. So we are using all the information given, okay, and also it's 1 query and 1 problem, right? And this part is called sub-query. This part is called sub-query. So basically it's a query inside the query. Okay, or sometimes we call it recursive query, or sometimes any other names. Trying to think of other names. Recursive query, sub-query, or embedded query, or so maybe all those names just refer to the same thing. Okay, so now let's run that, and we should get the exactly same result as this one. Perfect. So it's exactly the same thing, right? So at this point, I want you to practice using this syntax to try to practice a few more questions. Okay. Next question: can you find out the employees who make less than Smith? Find the employees who make less than Smith. Do that quickly. And let me know if you're already done. Or if you let me know, if you want to say the answer, that you want me to type the answer, say so also. So the point is, I want you to have all hands-on experience, hands-on practice during the class, because otherwise, just by purely listen to me is not does not get all the necessary learning from this kind of this type of classes. All right. Does anybody have questions about this? Simple, right? Just simply doing the same thing and less than, and then you're trying to find a Smith salary, right? So I'm going to skip that. Can I? Yes or no?
Yes.
Okay, so you should be fine with that one, right? So I don't need to give you the answer. So now let's try to do next one, which is kind of similar to that. Okay. So this time I say I want to find the employees hired before Smith. So what is Smith's hire date? That's a problem, right? That's a problem. That's unknown. So as long as you find the unknown, then you probably, just write the query as normal. So say, suppose you know Smith's salary, Smith's hire date. So then what do you do? So you say ename and then hire date, right? So this is the basic query from EMP, and then say, well, hire date is before, that means less than Smith's hire date. That's a question mark, right? So just put a question mark for now, and then let's say I want to use sub-query to replace that question mark. Okay. So just make sure you have a clear mind, that what is the main thing you want to looking for. The main thing is you want to find those employees. So that's individual cases, finding sourcing individual cases. Okay. And now let's try to replace the question mark by finding Smith's hire date. Okay, select hire date, and then from EMP, then ename is equal to Smith. Okay, and the subquery does not have a semicolon, but the whole statement will end with semicolon. The subquery will be inside parentheses. Get it? Okay, on that? Nobody? That's possible. What about greater than? Hire after Smith. Let me run that again. Okay, we have a lot of employees hired after Smith, so Smith is probably one of the employees hired earliest. Okay, so let me change that. Change it to after. Okay, after Smith. Okay, now just pay attention to what you're looking for. Okay, so here we are comparing this. Now that's employee that you're looking for, hire date for each employee you're looking for, and trying to compare his hire date with Smith's hire date. So make sure that this must be comparable. Okay, so hire date compared to hire date. So if you do something like this, so hire date and greater than cell, that would be totally wrong, right? So you cannot say that the employee looking for the hire date is bigger than Smith's salary. It's not comparable, right? It's not comparable. So make sure that the thing you're trying to compare must be comparable. So hire date. Is it clear? Okay, so I'm going to ask you to do next question. Can you find out the employees who have same job as Smith? Who have the same job as Smith? Do that quickly. Finish it? So this lessons like this, if it's online, if it's on site, then will be easy to tell whether you did or not. Do you have any questions or problems with this one? If not, I'm going to move on. Do you want me to show the result, so I type the result? Just let me know, okay? Trying to take the advantage of this synchronous learning, synchronous teaching mode.
Could you type it out, please?
Type it out. Okay, select. Ename. So we're looking for job, right? From EMP. And then we have to make sure that job is the same as Smith's job, right? Select job from EMP where ename is equal to Smith. Okay. So you're comparing job with job. Now do another example. Say, can you find the employees who is in the same department as Smith? Find the employees who are in the same department as Smith. So for every recording, trying to give you like 1 or 2 minutes, and then you use that time to do brainstorming and finishing the code. And if you have questions, then ask me. If you want me to write a code, ask me. You get it? Does anybody want to have a code?
So are you going to use join in this?
You don't have to use join. You can use join, but you don't have to.
It's like department name can use join. I mean, yes.
So because we're not looking for department name, right? Or we can just do join. Let's just do both. Okay? So select ename from EMP where the EPD number is equal to. So select the EPD number from EMP, and then where ename is equal to Smith. So in this case, we do not use department names. Now let's say if you want to use department name, let's see how we do that. So ename, and then from EMP number and EMP, and then in this case we are going to do join. Right? So this use department name, right? So we're going to do DPD in join, emp on dpt number equals to emp.dpt number. Okay, and then where dname is equal to, okay, select, so we have to select dname, okay. Let me just type here, from where? From we need to do join again, because this time we need to select department name for Smith. So from dpt inner join emp on dpt.dpt number equals to emp.dpt number. Okay, and well, ename is equal to Smith. Okay. So in other words, trying to make a department name as a way to search for employees, then we have to do the inner join. And then in the sub-query, we also have to select department name. Okay. All right, next. Can you find the employees hired in the same year as Smith? Find the employees. Hired in the same year as Smith. Okay. Did you get it? Let me know if this is too fast for you. Are you okay getting this? Do you want to answer? So in this case, you're going to use toChar to compare, right? So select ename from emp. Well, I need to compare the higher year. So toChar, date, get a year number. And that should be equal to sub-query. This is, well, okay, let me spell that. toChar. So in the sub-query, we need to find out the higher year for Smith. So select toChar, higher date, and then year number from emp, well, ename equals to Smith. Okay. So you see that all this kind of query have similar patterns, right? So just make sure that you know the basic stuff we learned in the previous classes can now be utilized here. Okay. And let's do one more of this, and then we'll go back to the examples. Okay. So find employees who work in the same location as Smith. So this time you compare locations. Okay, location is in the department table, so therefore you need to join. Okay, so select ename from, let's say DEPT, join, EMP on DEPT number equals to EMP.DEPT number. Okay, from now where location. So we're trying to compare location. So location, we also need to find out what is the location for Smith. Right, so that is a simple query, but we do need to use join. From DEPT, in join again, EMP on. Okay, in join, and then where ename equals to Smith. Okay, are you comfortable with this kind of query? So basically, just same pattern. All of them are using the same methods. It's kind of like use a sub-query to find something that is unknown. Okay, and also the unknown has to be comparable to the ones that you are using to search for the employees. Okay, so far we have not used any group statistics for these sub-queries, but we will have. So just make sure that you're very comfortable with this using the basic queries to come up with sub-queries. Okay, any questions? Now let me go back to the questions here. Oh, some of them already did. So for example, example 3 says find employees who have the same job as Smith. We already did that, okay? So now let's do example 4. Find employees.
Professor, I have doubt in this question. So,
Which question?
The one which we solved right now.
Oh, the one we are working at, same location?
Yeah, right. So in this query, instead of using join for join in the subquery, can we write it as where ename is equal to Smith and location is equal to, and then the subquery as select location from department?
Hold on, let's see. So you say select ename from department.
Right. And after that, where ename is equal to Smith.
Hold on, yes, tell me how to do that. So you can use this ename from what?
DEPT, department inner join employee.
Oh, you still need a join? Okay, join.
Yeah. On the same condition.
Okay. That equals to EMP.DEPT number. Okay, good. Then what?
Where ename is equal to Smith.
Ename equals to. This will be incorrect.
And location is equal to select location from department.
Okay, so you do that. So select location from DEPT.
Yes, that's it.
No, you cannot do that. That would be incorrect. So let's analyze here, okay?
Okay.
We are looking for employees whose name is Smith. Okay, but that's not what we're looking for, right? You are looking for the employees who work in the same location as Smith. So what do you find that is based on this part? Forget about this part. Okay, this part is incorrect. Just look at the first part. Okay, you'll find you only find the employees whose name is Smith. So that's just Smith himself. All right. Secondly, this is incorrect because select location from department. So there are many locations here. So you cannot say location equals to location. So this does not specify the location is for Smith. This is for all locations. So this subquery is going to find all locations. If I'm going to select that and run it, So you give that all these locations here. So now you're trying to say that the employee looking for the location equal to this, and that's not correct, because on one hand you have only one location. For example, employee has just one location, like Boston or New York or whatever, and then you say that location equals to this list of employees. You say that that's not correct. So
Okay. What if we do it as in instead of equal to?
yeah, that will be work. So let's say you cannot compare one value with a list of values. Okay, so remember that list of values. Okay, so now you say that what if I do this one? So there's in here. Okay, instead of equal to. So I have not talked about in parameter. So basically you have a list, and then you say this value is inside this list. Okay. We did the in. We use in for constraints, right? Did we do that? I think we did, right? So for example, grade in this list. Okay, so we can use in. So that will make syntax correct. The syntax wise is correct. So you find location is inside the list and name equal to Smith. However, this is still not answering the question. Okay, because this location is any location, right? So basically any location is listed. So basically you find an employee whose name is Smith and then working in any of these locations.
Okay, I got it.
Yeah, you got it. Okay, does everybody say that point? Okay, so this is wrong. Okay, so this is not right. Okay, very good. All right, so now let's move on to example 4. Finding employees who are hired before, I think, yeah, hired before Ward and after Smith. Okay, so we'll do that. Okay, so kind of like what we did before. So basically use hire date, right? But now you have two unknowns. So let's try to do that. Okay, say what are two unknowns? So select ename and then hire date, right? From EMP, and then hire date is before what? So is less than question mark. That's for Ward, right? And hire date after Smith. So another unknown. So basically you are just writing two sub-queries to replace those unknowns. Get that? Select, so this was wrong here. Oh, I missed a semicolon here. Okay. So this SQL developer does a good job. Give you just make sure that every statement is correct before you move on to the next one. So you will just simply say there's a word hire date, that is select hire date from EMP where ename equals to word. Okay, that is before word, and then after Smith. So sub-query select hire date from EMP where hire date where ename is equal to Smith. Okay. And then I think there's something wrong again. This one was not closed, parentheses. Okay. And the higher date is after, so this is greater than, so miss that also. Okay, so make sure each sub-query is inside parentheses. Then this each condition is complete. Okay, so no more question mark anymore. Okay, so here's a between. So basically, this less than. So you can also do between. In this case, between one date and another date. So now you have, in this case, you have to say which one is smaller, right? Is greater than Smith's higher date. So Smith's higher date must be smaller. So you're going to say between this and that. Okay, so I'm going to type that in a separate line. So you're going to say select ename hire date from EMP, and then we'll hire date between, okay, so between wage and wage. So question mark and the question mark, right? Okay, so semicolon also. So the first question mark must be smaller hire date. So which is this one? Because the number you're looking for is greater than this one. So this is smaller date. So we can just copy that and paste. Replace this one. Okay. And then for this one is bigger, so less than this date. So this one must be bigger date. Replace the second one. Okay, and then they should give you the same result. Okay, so those are the employees. All right, any questions? Does anybody have questions for this one? If not, let's move on to the next one. So here, find the employees who have no, find the employee department has no employees. Okay. Find the department that has no employees. Okay. So how do we approach this question? So it's tempting to do this, okay? Say select, okay, DEPT number from EMP group by DEPT number. And then say heaven count equal to 0. Can somebody tell me why this will be incorrect? Can somebody tell me why this will be incorrect? No employees. Department has no employees. Okay, so not total number of employees is 0. Kind of right. Kind of, you know, seems to be right, but if you look at, if you think of data in the EMP table, okay, for that particular department, if there is no employees, will you have department number listed in the department in the employee table? So employee table will have so every department, okay, every department number listed in the employee table has at least 1 employees, right? So there's no department that has no employees. So this will not give you any result. So if you try to run this, you will see 0, right? Nothing here. Okay? Does it make sense? So how do we solve this? How do we approach this question, this problem? So we're trying to find the department, okay? So what we do is, so in this case is not very clear what are you trying to compare, okay? But then let's try to start from beginning. So suppose I want looking for department, so that includes the department number or department name, the name from DEPT table. Well, okay, and then how do we say that this department has no employees? And then the only thing we just need to know is if this department number is not in the list of the department in the department table, in the EMP table. See that? So as long as this department listed in here in the department table, but it's not in the EMP employee table, then this would be the one we are looking for, right? Make sense? So in this case, we are using not in. So it's just the opposite to in. So here we select all the department numbers from EMP table. So those are the department numbers that have employees. Okay. Now, as long as this department number does not belong to that. So in this case, the question is, the subquery is not very clear. Okay, it's just like a previous case. You know what is subquery, what is unknown here, but you have to think about it a little bit. Is it clear? Okay, now let's do so this one. So largest department, I'm going to postpone example 6 after this one. Okay, let's do 7 and 8 first. So 7 will be kind of similar to the one we did here. So you're trying to find employees supervised by Blake. So in other words, those employees have a manager as a Blake, okay? So let's try to look at the entire tables. You can just figure out how do you formulate the query. So if I just get all the data we have. So let's see, employee, for each employee, we should use, how do we find the manager? For example, Jones here, okay? Jones has a manager 7839. Who is 7839? Here is the king, the president. Okay, let's use another example here. So this one, Ford. So employee number 7902, right? Ford. And his manager is 7566. Who is 7566? 7566 is Jones. Okay, so it means that Ford, the manager for Ford is Jones. Is that clear? So now you're trying to use this idea to come up with a query to answer the question. We want to find the employees, so we say select ename, okay? Or maybe just ename from EMP. And then what I'm looking for, the employee we're looking for whose manager number is equal to what? Blake's employee number. So this again is kind of like, the subquery is, the question mark here is the manager number equals the Blake's employee number. Okay. Select EMP number from EMP, well, ename is equal to Blake. So again, select. Again, this query just like a previous one, as a as a little bit twist on how to find unknowns. What is the unknown you're looking for? Yep. Does it make sense? Now let's move on to example 7. Example 8. Okay. Find employees located in Dallas. You think this is a pretty easy one, right? We already know how to do that. So just use a join, right? So now let's say without using join, let's use subquery to do it. Okay. So we want to find employees. Select ename from EMP. Okay. And then, well, so again, this time we need to link the department with employee through the department number, right? So, well, DEPT number, and then that would be in, say, which department is in Dallas. So select DEPT number from DEPT, well, location is equal to Dallas. Like that. So again, this query also shows that sometimes you need to twist a little bit about what is unknown, what is subquery you're looking for. Okay, so let's analyze the question. We find the employees located in dollars. So we can find, so how do we link the employees with dollars? Is through department number, right? So we just make sure the department number is in this list. Oh, by the way, can we use equal to in this case? Can we use equal to, department number equal to that? I think so. It's probably okay. However, if you have multiple departments in one location, then this will be a problem. So if each department, each location has only one department, then this will be right. Okay, this will work. So equal works if each location has one department. Okay. Otherwise, use in to replace equal. Does it make sense? So if there's multiple department in one location, then this will be list. So you cannot say a value equal to list, right? One value equal to list, that will not be fine. But you say one value in the list, that's okay. Okay. So in general, in will be better. Oh, by the way, if this just have like one value, if this subquery give you only one value, can you use in? Yes, you can. So in actually is more general than equal to. Okay, so basically if a list has only one value, that should be fine too. So in is more general than equal. Okay. So we walked through examples in which that subqueries are sometimes not that clear. Sometimes are not that clear. So those are three examples. So let me just put a point out here. The following three examples show some twist with subqueries. Okay, of course, that's what we are trying to train you guys to be, right? You're trying to be like an intelligent program writer. If everything is, can be done mechanically like that once before, then just machine can do it, right? I can develop a program to do that. Okay, so this is there's no surprise. Okay, so maybe sometimes you may think that writing this kind of SQL statement is getting more difficult, more complex, and maybe more difficult than writing Java or C# code. Okay, and indeed, sometimes can be more difficult. All right, so now let's try to use group statistics to do search as a subqueries. Okay, so I'm going to just start with something simple first. So let's say, suppose you want to find employees. Okay, employees who make more than everybody in dollars. But let's just try to do something. So more than all salesmen. Simple first, okay? All salesmen. Okay, so here, find employees who make more than all salesmen. So you're trying to say select, okay, ENAME from EMP, make more than, so salary is bigger than the question mark, right? Question mark. So more than all salesmen. So now you're quite trying to say, how much does this salesman make? Okay, so you're trying to do something like that. It's trying to say, select cell from EMP, and where job is equal to salesman. Right? You're trying to do that. But then you see the problem here, you're comparing one person's salary with list of their salaries here. Because there are many salesmen, right? And each one have a salary. So this one will give you a list of salaries, one for each salesman. So you're trying to compare that particular employee salary with that list, and that should not be allowed. Okay. However, there are two cases you can solve this problem. So this will not be allowed. Okay. Allowed to compare one value with a list using equal, greater than, and less than. Okay, so we already did like a equal to. So in the case of equal to, you can use in, but in case of greater than, less than, what do you do? So there is one solution. So solution one is add keyword or any or some before the list. So this is the first solution. Okay. So what does that mean is that here, let me just copy this one first. Okay. Paste it here. In this list, okay, in front of this list, we can add a keyword like or. That means or. That means that the salary you compare will be bigger than all of these values. In that case, that will work because we're trying to find employees who make more than all employees, right? So that's all. Okay. But you can also add any. So that means you find employees who are making more than some employees, or you can use some. So that's equivalent. Okay. So you can add those keywords in front of list. When you're trying to compare a value with list using greater than or less than. Okay, so in our case, should be all, right? It's not some. So we have to make sure that the salary is bigger than all of them. And let's run it. Okay, so those are the employees who are making more than all salesmen. Okay, now what about the solution two? Use group stat. So what if let's copy this again. Okay, copy that again. So this time I want to find the salary is bigger than all of this. So if it's bigger than all of this, then it should be bigger than the maximum of this employee salary, right? So we can just add max instead of finding salary, compare salary with individual salaries. We can just find the max salary for all the salesmen. So if those employees of employee salary is more than the maximum of their salary, then that would be also correct, right? That would be also correct. So this is second approach. So you get the same. So should get the same answer. Okay. So in other words, you can use group statistics to help you to formulate sub-queries. Does it make sense? Okay, so now let's try to do a few more here. Okay. Now, can you find employees who make less than everybody in dollars? Find employees who make less than everybody in dollars. Okay, so let's start. So select ENAME. So since we select income, right? So let's also do that from EMP. Okay, and then what I'm looking for is a salary is less than all employee salaries in dollars. So we can use a max to find out what is the maximum salary in dollars. So select max of cell from. Let's do the join. In the join EMP on EMP.dpd number. Okay. So So it's trying to say that join that, and then you say where location equals to dollars. Okay, so that will be okay. So you can find the maximum salary for people in dollars, right? Okay. Okay, now let's do something along this line, send a few more similar ones, and then we're going to go back to the example list again. So this time, let's say I want to find the employees who are making more than everybody in the department that Smith is located. Find employees who make more than everybody in Smith's department. So select the name from EMP. Well, salary is bigger than, so the query, the first part is easy, but the question is how do we find a sub-query? Sub-query is that you want to find the maximum salary for everybody in Smith's department, right? So we can do select max of cell from EMP. Okay. And what? And those maximum salary for the department. So which department? The PD number. Okay, the PD number equals to. So we are going to use another sub-query inside. Find Smith's department, right? So that will be select the PD number from EMP, where ename equals to Smith. So this query is kind of using two nested sub-queries. Sub-query use sub-queries. Okay. Is that comfortable? Are you comfortable with this kind of query? So basically, whenever you have unknowns, just put a question mark and then replace it with simple queries. Always start with simple queries. Main query first, start with the main query, and then put a question mark to replace unknowns, and trying to use sub-query to find unknowns. So sometimes like this, you're going to get a little bit of nested sub-queries. All right, you want to do one more? We move back to the example. Find employees. Okay, hired after everybody in sales department. So you're trying to use hire date to search for employees. So you select ename from EMP, where hire date. So hire date is after, that means greater than what? Everybody's hire date in sales department. So we can just find the sales department hire date for everybody in the sales department. And then we can do, say, select max of hire date from EMP. Okay, and then how do we find the sales department? Well, we have to use another sub-query. So where the PD number is equal to inside. So find what is department number for sales, right? Select DE number from DE where dname is equal to sales. Sub-query, close it. So you have two nested subqueries again. So select maximum hire date for people in sales department. So that is, so to find the department number for sales, we use this first level, the inner subquery. And then from that, we find what is maximum hire date for that department. And from there, we'll be able to find we'll have hire date after all that. So getting more complex, right? Okay. Now let's go back to see what we'll look at the questions again. So we have out of this subqueries, we have 3 more examples. I'm going to do largest department, jobs that have the maximum average salary, and find the department that have largest total salary. So now those 3 queries are pretty much similar. So let's do that as a group. So let's do one first, and then I will do, I will take a break, then we'll do this other 2 after the break, okay? Find the largest department. So how do we interpret largest department? There's a department count, number of employee count, right? Head count, okay? So let's say that we want to find a department that has, the count is biggest. Okay, so remember for group statistics, okay, so we have to use group statistics, right? So select, so in this case, we are doing like a factor selection, okay? Select the factor. So select which one? So let's just start with something simple first. Select department number, okay? From EMP, okay? And then we do group by DEPT number, okay? And then say heaven, and then we do count, okay? So count what? Count employee number, right? Or count star. And that should be than largest or bigger than or equal to what? Equal to all the counts, all the department, all the employees count. So that means the number of employees for each department, the number of employees. So let's do the simple. Let's say so. Let's put a question mark first here. Okay. So if I give you a query, that query start with simple ones first. Okay. Let's say if I want to find out the total number of employees for each department. Okay. Select count and then EMP number from EMP and the group by DEPT number, right? So if I run this query, that should be very simple. That will give you all the counts. Okay, so for example, 6, 5, 2, 5, 1, 3. So those are the employee counts. Okay, so you can tell that which department, the first one has largest count, right? So our job is trying to find that one. Okay, find this department, which department has 6. Okay, so what do we need to do in this subquery here? We are going to replace by the list. Okay, replace by the list. All right. So let's put. We can put into next one row so that we can see everything clearly. All right. So basically, you want to say this count you're looking for the department you're looking for is greater than or equal to this list. So I'm going to get rid of the semicolon because subquery should not have semicolon, and the semicolon should go outside for one statement. Okay. So this subquery will give you the list of accounts like this. Okay. So now you have a question here, and in this case, you have just one count. So if for each department you have one count, the count could be either 6 or 2 or 5 or 1 or 3, right? So you want to use that value. The count value is bigger than or equal to this list, and that is not allowed. So what is alternative? We can use all in front of here, right? So as long as this count is bigger than or equal to all of them, then this department is what I'm looking for. Let's run it. And again, the department 30 is the one showing that. Okay, So in this case, only solution 2 would work. So previously we said we can use this, instead of this, we can put a max here, put a max, and then say max count. That will not, that's not a group function. You cannot put a group function inside a group function here. So this will not be allowed. Okay. So no, not allowed to have group function over group function. Okay, so this will not be allowed. So this, in this case, only all will be the choice. Okay, so correct one will be just using all. So instead of using this max, okay, you have to use all. So just make sure you understand the question. The question is find the largest department. So interpret that is that department who has a count is bigger than or equal to all the counts. Okay, so let's run it. We already run it, so this should be give you the answer. This is 30, department 30, which has a number of 6. Okay. Does it make sense, everyone? So basically this is getting a little bit more complex, and after we finish this more complex examples, then we will probably go back a little bit, relax a little bit, do some simple ones, and then we'll spiral up again and do more complex ones. Okay. So I don't want you to have like a pressure that is always going up. Just getting more and more difficult. All right, so let's take a break until 8:40. Okay, and let me start temporary. Okay. So next question, just kind of like this. This time I say I want to find a job. Okay, selecting job that have maximum salary, maximum average salary. So kind of tempting to do max average salary, right? But you cannot do that. Okay. So basically, since you're going to find a max, then you have the greater than equal to all. So here we are using average salary to select jobs. So let's do that first. So select job from EMP, and we do need to do group by because this is basically statistics, right? So group by job, and then we say heaven, and then say heaven the average salary. That's what we are looking for. So this average salary is bigger than this list. Okay, so our sub-query should be able to find average salary for each job. Remember, that is what? That's just like a simple factor analysis. Okay, so we can do that first. Select average cell from EMP group by job. As simple as that. Okay, but then here there's a list. This is a list of salaries, average salaries. But we're trying to make sure that this is greater than all of those. So we have to put greater than or equal to all. Why equal? Because we need to find one average salary is equal to some of this, right? Equal to one or some of this. So we have a list of salaries, but one of them is a maximum. So the salary you're looking for, the maximum salary, the average salary you're looking for is one of those, but that is one that is bigger than or equal to all of those. Does that make sense? So let's say president is one. Okay. And then let's do the last one, and then we do probably give you one more, and then we'll just move on to other questions. So we do not have many here. So we have access like additional practice questions. So we just do this one. So here, this example asks you to find the department that has largest total salary. Largest total salary. So you are using sum of the salaries among all departments. Okay. So here the department could be just department number. So we are looking for select DEPT number from EMP, group by DEPT number, and then say having sum of the salary. Okay, so you finish the rest. Finish it. So it should be greater than or equal to all, so because that's the largest, right? And then say select sum of salary from ENP, and then group by the EPT number. Okay, so this kind of a query appears to be complex, but then if you realize that if you can do this kind of a query, that is the factor analysis, find every total salary for each group, for each job, for each department, for each year, for each then you basically from that just get a sense which department or which job you're looking for. Okay, so because the same main query and the sub query kind of like a symmetric. So here you do group by and then have a sum, and here this is finding all, select group, select sum, and then group by the same thing. Okay. All right, so now let me give you one question that you do it yourself, and then say find the year.
Here's something I found on answers.com. Charles, Chick left Veneto, son of Posey and Lynn.
Alexa, stop.
Catherine.
Alexa, stop.
Maria, former pro baseball player.
Alexa, stop. Sorry for that. I don't know why it's triggered Alexa to come up. So find the year. Find the year that company hired most employees. Okay, so you do that and then see whether you can do it without my help. You get it? Got it up. So let's say let's do it together. So we want to find the year, so you're going to use toChar again, hire date, and y from ENP, and then we need to group by the year by the same thing. Group by hire date, y. Okay. And then we say having. So this time we say hire the most employees count, right? We count the number of employees is most, so greater than equal to all. So we just need to get the employee counts for each year. So that should be simple factor analysis type. So select count from EMP group by. We'll have to do the same thing, group by the same year number also. Okay. Let's closing that parents. Okay, then we have to have another parenthesis close. Okay. So let's see. 91. All right. Are you okay with this kind of query? So this probably will be the most difficult ones we are looking at tonight. Of course, there will be some queries which will be more complex than this one, but we'll approach that next week. Okay. So today we'll just now, that would be the most difficult ones, and then let's relax back a little bit. Let's do some other simple ones. Okay. So far we just pretty much use sub-queries for select statements, but of course you can also use sub-queries for other type of statements. So let's practice some of those. So here we said file employee under forced supervision. So you need delete, right? So let's do that. Copy this. So let's say I delete everybody under forced supervision. So that means delete everyone whose manager is Ford. Okay, so delete from EMP. Then I say, well, so now whom to be deleted? Delete those employees whose manager is equal to false employee number, right? So let's find this false employee number. There's a sub-query. So select EMP number from EMP, where ename equals to Ford. Like that. Okay, so kind of just like one we did before, to trying to find the employees under forced supervision. Then you select for EMP where manager equal to that. So basically, just kind of same kind of questions. Okay. Next, question 2. Delete the salesmen who were hired before turnover but never received commissions. So delete before turnover. So delete. So the portion you want to delete are the salesman. So job equals the salesman, and also hire data is before turnover. Select, not select, delete. Delete from EMP. Well, job is equal to salesman. Okay, is one condition. And hire date is must be before turnover's hire date. So here the question mark sub-queries. Okay, and have never received commissions, and com is null or com is equal to 0. Okay, so if we just finish the main query like this, then that should be simple one. But now we do have unknowns, so the unknown is replaced by sub-queries, which is also a simple one. So turnover's hire date. So inside parentheses, put turnover's hire date. Select hire date from EMP, where ename is equal to TORNEL, turnover. There we go. So where sub-queries can be used? The sub-query will be used inside the where clause here. When you have a delete statement, and the where clause can use sub-queries. Okay. Anything else? Delete from table, the name of table, then you cannot use sub-queries here. Okay. Only place you can use sub-queries inside the where clause. So some kind of condition that requires some kind of sub-query to find out. Okay, so now next, let's do update. So first, let's do example 2. That is simple one. Now James now reports to Blake. Okay, so now James now reports to Blake. So you need, what do you need to do? You need to change James manager, right? You need to change James manager to Blake. Okay, so update emp set manager equal to question mark. Okay, equal to Blake's employee number, where name is equal to James. So that is the main query. So sub-query, easy, just find Blake's employee number. Number from empty. Well, name equal to James Blake. Okay. Excuse me for a second. So in this update statement, we use sub-query inside the set statement. Inside the set, there's the well has something wrong here. Oh, there's a parenthesis closed. Parenthesis must be closed. Okay, so manager equals to something unknown equals to Blake's employee number. So basically, this sub-query is inside the set statement, set clause. And now let's do other questions. And so this time you will find that sub-query can be used in set and also where clause. Okay, so next one. Except for managers, for all the people working in Boston, change their job title to operator and add $50 to their salary. Okay, so except for managers, so the job should not be manager. Okay, and for all the people working in Boston, change their job title to operator. So that's first one should be easy. Update emp set job is equal to operator. Okay, comma. And then also add $50 to their salary. So salary equals to salary plus 50. Okay, but then this part should be simple. If we don't say that, look at the people working in Boston, right? So now we just need to figure out how do we do Boston, and also for managers, not for managers. So where job not equal to job not equal to manager. Okay. And location is Boston. So Boston is in department table. And remember that you cannot use join for update. You cannot say update emp join something, right? You cannot do that. Okay. So you can only update one table at a time. You cannot do multiple tables. So sub-query is the only way we can do it. So how do we link to that? So we have to use sub-query to do that. So just make sure that those employees you're looking for, whose department number is inside Boston department. So select the PT number from the PT, where location is equal to equal to what? To Boston. Sub-query. Okay. So this type of sub-query is no different from select statement, okay, except that this is for update. Got it? Okay, let's do last question here. Mila is now promoted to be a manager, so let me copy this first. Mila is now promoted to be a manager, and his salary is going to be smallest of all current manager salaries. Okay, so what do we need to do? So Mila, his record has to be updated. First of all, his job title is a manager, so we need to change that. And his salary is also going to be changed. Okay, so let's do that first. Update EMP set job equal to manager. Okay, comma salary equal to. So this is something I don't know. We don't know, so it's unknown. We just say the smallest of all current manager salary. Okay, so of course we're going to use sub-query to find out what is the smallest salary for current managers, and then this update is going to be for Miller only. So ename is equal to Miller semicolon. Okay, so this is the main query. If I give you the salary, then this is not a problem. So now the question is, we need to replace that with sub-query. Okay, and that's not difficult either, because we can find what is the smallest salary of all current managers. Okay, select minimum cell from EMP where job is equal to manager, like that. Okay, so again, this question is using sub-query inside the set statement, and so we have example showing you that sub-query can be inside set and the where clause for update statement. Okay, so you probably will find out that sub-query will be more often to be used when you for delete and for update statements, because you cannot join multiple tables. So every time if you need information from different tables, then you have to use sub-query. Okay, unlike select statement, you can join multiple tables so that you can avoid some of the sub-queries. So that makes sense. Okay, and let me say that is all the questions. We can also do insert. I do not have example for insert here. Do I have insert example here? We do not have example for insert. Delete. Okay, so we can just create one here on the fly. Okay, insert one department. Okay, for say let's just try it for department. Say department is marketing. Department. Okay, which is co-located with sales. Okay. So that means the only thing we know that is the name of department, marketing. The location is unknown, right? Location is unknown. So, but the department number, we can just use some kind of sequence number to generate. Do we have the sequence? If not, we just create a new one. So we'll say insert into, okay, into DPT. Okay, so we have department number, DNAME, and the location. Okay. And then values. Oh, by the way, let's just say the department number is not something we don't know. So we can use find the current, what is the maximum department number, and then increase, just add 10 to it. Okay, so for example, if the maximum number is 50, then we just add a 10, that will be 60, so something like that. Okay, so we are going to just use so question mark first, okay? And then first one, something we know is department marketing. Okay, the name of department, marketing. Okay, and then another one is location, also unknown. Okay, so again, we can just replace those question marks with sub-queries. Okay, so first one, so the maximum department number plus 10. Okay, so we'll do parentheses inside that. We'll do say select max DPT number plus 10 from DPT. Okay, so that one sub-query to find out what is new department number. Just say whatever department number, maximum number plus 10. Okay, and then replace this one with another sub-query. That sub-query is trying to find out what is location for sales. Okay, so for sales department, so select log location from DPT, where DNAME is equal to sales. Okay, that's it. So you can also use sub-query to find the values to be inserted into tables. Look at that. All right, so we have, I think we are approaching to the end, 9:10. So let me see whether you have any questions at this point. No questions?
Can we use insert statement inside an insert statement? I mean, if suppose for insert here, we have used select, but what if we have to use insert again? Can we use it in that way?
Say that again. Say your question again. I think you.
Okay, my question is, can we use two insert statements in at one clause?
Oh, you one. Yes, you can. So
Yeah,
basically,
okay.
this is just sub-queries here. The sub-query is going to find unknowns, and then the unknowns will replace the question mark. So yes, you can use any number of sub-queries. You can also use sub-queries inside sub-queries to find whatever you're trying to find, and then use that value to insert. Just make sure that when you do insert, you can only insert only one value at a time. Okay. So if sub-query find multiple values, then you cannot do it. Okay. And I will tell you how to do that. If you select multiple things, get multiple results, and then try to insert into a table, then you have to use different syntax. Not this one. This one allows you just insert one record at a time. Each record has only one value for each cell, right? So make sure that the select statement gives you just one value. Okay, yes, but you can use multiple sub-queries inside one statement, like that. Just like what we did with select statement and where clause, you can also use multiple sub-queries. Okay. Any questions? Any other questions? No. All right. If there's no more questions, let me double check your homework. Your homework has 20 questions. Unemployed make more than ever opening accounting, delete all salesmen, give to, yeah, it should be all doable. Should be simple compared to what we did in the class. All right, and that's it. And I'm going to stop recording.